Hey everybody. So just quickly about the bell ringer. We have this scenario. A roller coaster has a mass of 50 kilograms and is going 25 meters per second. It says, which type of energy is it, and calculate its energy. So for the type of energy, we wanted to know kinetic or potential. If it's going 25 meters per second, then obviously it has kinetic energy, right? So the energy equation that you're going to use, kinetic energy equals 1/2 mv. Nope, just kidding. 1/2 mv squared. Okay. When you're calculating its energy, you need to know that equation. And then also, what is the mass? And what is the velocity? So when we're thinking about the mass, obviously we're looking for kilograms. So we've got 50 kilograms and 25 meters per second. Okay. Our next step is to plug in the numbers. So kinetic energy equals 1/2 times mass, which is 50 kilograms, times velocity, which is 25 meters per second, and squared. Okay, put that into our handy dandy calculator. Okay, back. We got our calculator. We're going to do 25 squared times 50, and then times 1/2. So what we get is 15,625. Let's adjust this. So 15,625, and then we got to think, what is our unit? And for energy, it is joules. All right. So we're coming back to our energy notes. We're going to pick up where we left off on conservation of energy. Okay. So energy can't be created or destroyed. But it can be changed, which we're going to call transformed, okay? So on your paper, you need to make sure that you write down all of these words. Energy cannot be created nor destroyed. It is transformed, which means the same thing as change, okay? So we can change energy into a different kind, like when your ball is sitting on the table and then it falls off, right? It had potential energy before and now it has kinetic energy, but it can't be created or destroyed. You have to get it from somewhere. Right? Kind of like your body needs food, and your food gets energy from the sun, and the sun gets energy from nuclear reactions, etc., etc., etc. Okay? So, one of the questions says, where does the coaster have the most gravitational potential energy? And if you think back to what we talked about yesterday, GPE is higher wherever the height is highest, right? So it's going to have the most energy up here at the top, the most gravitational potential energy, right? Now, that's different than saying where does it have the most kinetic energy? Because when it has the most kinetic energy is when it's going the fastest, right? So where it's going the fastest would be kind of at the bottom here when all of that potential energy all turned into kinetic. Okay, make sure you write down an answer for that on your notes. So, for mechanical energy transformation, right? This is the sum of the kinetic and the potential energy. So you're going to add up the kinetic and the potential energy depending on what is happening in that situation. Okay, in this picture, let's zoom a little bit. That didn't zoom. That is zooming out. Okay. Oh my gosh, it's getting worse and worse. There we go. Okay, so in this picture, what this is saying is that this person has a lot of potential energy and not a lot of kinetic energy. Here, this person has a lot of potential energy and no kinetic energy because they're at the top, so they're not moving at all. It's kind of like the hang time if you think about elevator stomach, right? Before you start to move, you kind of get that stomach that goes up. This person has a lot of kinetic energy and less potential energy. This one has the most kinetic energy because you're down here at the bottom moving the fastest. And then again, it starts to go back down and potential energy starts to go back up. So at any point here, the mechanical energy transformation is adding up these two. Here it's just potential energy. Here you're adding the two, adding the two, adding the two, and adding the two. All right, other energy transformations. So remember, energy is never destroyed. It's just changed or transformed. So make sure you write that down on your paper. There's 6 other kinds of energy transformations that we're going to talk about. So the first one is thermal or heat energy transformation. Then we have light, sound, chemical, which is from chemical bonds, mechanical, which is the one that we just talked about, which is gravitational potential energy added to kinetic energy, and then electrical energy transformation. Okay, when we are talking about energy transformation examples, right? If no energy is lost, why does the girl eventually slow down? So, energy starts, okay, I want you to think about this first. So pause the video and think, why does the girl eventually slow down if no energy is lost? So what we're saying is it's not created, it's not destroyed, right? But why does she slow down then? Okay, so in this case, when she's moving, energy starts as mechanical, right? It's gravitational potential energy depending on where she is, and kinetic energy if she's moving, right? Then, as she's moving, it's transformed because you have air resistance, this way, motion that way, and friction going on up here. So one of the things that gets transformed into is sound energy, because you know, if you've ridden on a swing set, that this is making noise, right? Another thing that it can get turned into is thermal energy, because you know from friction creates heat. All right, next one. So we have electrical energy coming from the socket, right? It goes up into this light bulb. And obviously I just said the answer, which transforms into light, right? And a little bit of heat energy as well, because as we all know, if we touch the light bulb, it's hot. All right, so here's a fire. A nice little bonfire. And we have wood that's being burned. So if you think about it, wood, before it's being burned, is filled with chemical bonds, right? There's lots of good stuff in wood. So it has chemical energy before it's being stored. As it's burning, we all know fire is hot, so it's transformed into thermal energy, right? Heat. So it starts as chemical energy and transforms into thermal energy. Alrighty. Well, the cell phone is a little dated, but you can imagine what it looks like now. We have this charger that's plugged in. So this energy starts off as electrical energy, right? And then up here you have your screen, which is light and sound, depending on what is going on up there, right? That's a pretty flower. I don't know. All right, so that concludes your energy notes. What I want you to do right now is pause this video, take a minute, and write your 3-sentence summary, okay? This is your last summary of the whole year. Way to go. Clap, 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 clap. All right. Make sure, if you're not sure what to write for your summary, as always, answer these questions. So what's the most important part of these notes? Read back over them since it's been 2 days. Why are these notes important in science? Lots of science in here, guys. I'm sure you can talk about this a lot. And then, was there something that was confusing? Was there something you already knew? Was there something that seemed really easy or straightforward? Okay. You have 2 more assignments to do today. So one of them is an energy transformation worksheet. It's a lot of practice problems, just kind of like these. And then one of them is called Energy Skate Park. So you're going to go to this FET right here. Let me see if I can show you. Okay. You're going to play it. I hope it plays. That would be embarrassing. It's not going to let me move the screen, is it? Oh, there we go. So you've seen these guys before. On the paper that your sub is going to give you, it's going to have, like, what should you do as you go through these things? What are you supposed to do with this little kid that's skateboarding? How cute is that? Okay. So go ahead and do that. Anything that you don't get done today, as usual, is homework. Okay. So make sure that you finish your summary. You get your energy transformation worksheet done and your energy skate park. If you didn't finish your kinetic and potential energy practice yesterday, tisk tisk, get it done and make sure that it gets turned in. Have a great Friday. See you soon.